Bismillahirrahmanirrahim. In this video lecture, we will understand the concept of black hole, its physics and mathematics. We will try to explain everything in very simple words and with the simple mathematics. So let's start. What is a black hole? Black hole is a region where escape velocity is greater or equal to speed of light. So the region black hole is a place where the escape velocity become greater. I will take greater than the speed of light, c. So this is the condition for that region, which is called black hole. If the escape velocity of a body from that region, mean near the singularity, become greater than the speed of light, then that region is called black hole, or that body is called black hole. This concept is predicted by general relativity, and there is a concept of even horizon. From here we can understand the concept of the black hole more easily. Let's say here is the singularity and a surface where the velocity for any body is to be c, velocity of light. If somebody want to reach this surface, the velocity should be c for that body. This surface is called even horizon. So even horizon is a surface even horizon is a surface where a body achieve the speed of light. So that body will move over the horizon with this speed. If its speed become less than the speed of light, then that will fall into the black hole. They will not sustain the motion on the horizon then. So a body should be moving with the velocity of light to maintain its existence over the horizon. Okay, what is the escape velocity? This is the equation of the escape velocity. So we have to derive this. This is, in fact, I am writing it again. Escape velocity is equal to under root 2gm over r. This whole is under the root. Where G is the Newton gravitational constant, m is mass of the black hole, and r is the Schwarzschild radius. So this is the formula for the escape velocity. We want to derive this formula. So for this formula, we have to equate the gravitational potential energy to the kinetic energy. That is 1/2 m v square is equal to G capital M, which should be mass of the black hole in our case, m over r. So these two m's will cancel out, and we get v square is equal to 2g capital M over r. If we take the root on both sides, we will get the velocity, which will be the escape velocity of a body of mass m. This is the escape velocity of mass m. So if this mass is the earth mass, then it will give me escape velocity from the surface of the earth. If we put this escape velocity equal to the speed of light, okay, so this is the escape velocity formula, and when we put this escape velocity to be c, so we find that v square is equal to 2gm over r. So when we put this condition, c square is equal to 2gm over r, and we find the r in that situation, 2gm over c square. This is c, velocity of light. Let me write it again, 2gm over c square. So this value is called the Schwarzschild radius. This is rs Schwarzschild radius. So when the escape velocity become velocity of light, at that situation the radius become the Schwarzschild radius. So this is the Schwarzschild radius. Okay, this is the Schwarzschild radius. So putting m, let's say if someone is interesting to calculate the Schwarzschild radius of the earth, then put the mass of the earth in this formula. We will see that the radius is about 8 centimeter. So calculate it. Put g and mass of earth and velocity of light, and calculate it for the earth. So we will find the Schwarzschild radius of the earth. So that means if it is 8 centimeter, there, what that mean? The whole mass of the earth, whole mass of the earth will be accumulated in a region whose radius is 8 centimeter. So at that situation, the earth will behave like a black hole. So the object whose radius is less than the Schwarzschild radius, okay, we get that the Schwarzschild radius is 2gm over c square. If r is less than or equal to the Schwarzschild radius, in that situation we get a black hole. Even light will not escape from that region. From this region, where the radius is less than the Schwarzschild radius, the light itself is trapped and cannot be escaped from the region. So this is the condition for the black hole. The region where, so first we have to accumulate the mass into the Schwarzschild radius. So r less than the Schwarzschild radius then is the region of the black hole that lies inside the black hole. Simple example is the Schwarzschild metric. So I'm writing it again for simplicity. d square is equal to 1 minus 2m over r dt square minus 1 over 1 minus 2m over r dr square minus r square d theta square plus sine square theta d phi square. This is the Schwarzschild metric. Here the mass m is mass of the black hole. And horizon is equal to, horizon of this is defined when we put 1 minus 2m over r equal to 0. So that will give me okay, that will give us r is equal to 2m. This defines the horizon of the black hole. When we put r equal to 2m, that is the singularity, horizon singularity, and the whole mass of the black hole is accumulated. So you can say this is Schwarzschild radius. Schwarzschild radius is equal to 2m. So r less than rs, which is 2m. So this r then define the black hole region, and from that region light cannot escape. Light itself cannot. Nothing escape, even light trap in that region. Okay, so even horizon, we did it. Even horizon is equal, r is equal to 2m. This is the boundary of no return. So the even horizon is, here is a singularity and here is the horizon. So this, if somebody reach to the horizon, that is point of no return. That body will never ever escape. That is trapped on the horizon. The light cone is tilt inward in that region. Mean the body can go inside the black hole, but it will not leave the it cannot leave the black hole. Okay, so let a little bit discuss the time dilation. So the proper time T proper is equal to T under root 1 minus let me use the original formula, Einstein relativity formula for the time. This is c square. So how to derive this formula? We see that 1 over 2 mv square is equal to, mean kinetic energy and potential energy are equal, G m capital M over R. So this m will cancel with this one, and v square is equal to G m over R. So when we put this value over here, what we get? T is T under root 1 minus, so that is the value 2 Gm over, so this is C square and R. So that is the formula. but we use that G and C geometric units are equal to 1. In that case, we get the formula T under root 1 minus 2m over R. Okay, so this is the time, the proper time and the time formula. This time, proper time becomes 0 if I put on the horizon. If I put R to be 2m, R to be 2m in this formula, this becomes 0 and proper time becomes 0. What that mean? On the horizon, the time stop. Time does not pass, it is 0. So whatever is this time, the time of the time on the horizon is 0. This is the proper time. So what that mean? That mean a body, when a body reach to the horizon, its time stop. So its age will remain that age forever. Away from the horizon, this will be the proper time, but always be less than TP is less than T is the situation. Proper time is always less than the time. So this formula shows that on the horizon the time stop. Time is 0. Okay, thank you.